Hi folks, this is PCSB Projects. Today we'll talk about a very powerful single board computer that is very important for the future of all the PCs. We'll try to find out an answer to a very intriguing question, whether these kind of single board computers are already the first full-fledged PCs with an alternative ARM64 architecture. We're gonna explore the features, the performance, and what these computers could be used for. I finally got my hands on one of the first single board computers of the 6th generation, which easily competes with the classic desktop PCs and mini PCs. However, in contrast to mini PCs, single board computers are usually purchased without the case except for those which are included in a relatively expensive kit. Though it is usually easy enough to purchase a suitable case from an internet computer store, you may also use your imagination to build a dream case that may be even more attractive. I prefer to recycle old devices or to use leftover parts, like this giant Lego brick that used to cover a paper box with a Lego set. There is not only enough room for HWiNFO, but there is enough for inbuilding a proper graphics card with a tremendous 3D acceleration. Though HWiNFO, unlike Retsa Orion 06, has no full-sized 16-lane PCIe connector, you can still attach a graphics card through a 4-lane PCIe adapter from a M.2 connector to a full-sized 16-lane PCIe connector. The adapter will only cost you about €15. You still need an ATX power supply, though there is gonna be only 4 active PCIe lanes to transfer data instead of 8 like on Retsa Orion 06. It's still gonna work much faster than the inbuilt graphics processing unit. But even without a graphics card, HWi6 can outperform an older classics PC with its 12 processing cores and an inbuilt graphics processor ARM Immortalis 720 with 10 additional graphics cores. It's usually 2 to 3 times faster. And I'm not talking about very old classics PCs. Mine's also got an SSD drive, but it's an old style and it connects through an SATA port. Comparing a classics PC to a single board computer, though, it's really not easy because each of them is usually running a different kind of operating system. To make absolutely sure that a single board computer is faster than a classics PC, you have to test it with the same software as you are using on a classics PC. What really counts at the end of the day is a number of tasks that you can perform a number of times faster, like rendering a video, which requires a fast data drive as well as a lot of processing power. I've built a 512 GB NVMe SSD drive into my HWi6, which is a number of times faster than an SATA 6 connected SSD drive. However, this would have not been enough if there were not 3 times as many cores in CIX P1 system on chip as in the old quad-core Intel processor. As I've already mentioned, to beat a classics PC on its ground, a single board computer has usually no other option than to run Windows, and I've decided to run Windows 11, which should be easy to do according to the instruction manual. It is one of the 3 instruction manuals for installing Linux, Android, and Windows. In the later, there is a link to a Chinese cloud where you can download a version of Windows, but it turns out that this version might not even work even if you manage to download it. Instead, I went to uudump.net and obtained Windows version 22H2. Next, I've browsed the Rufus IE webpage and downloaded the latest version, which was 4.11. If you don't already know Rufus, let me just tell you that it is an installation tool that makes a bootable installation media from an ISO file, which you can insert into your computer's USB port to install an operating system to a suitable data drive. You can also use version 4.4, which is available from HWi website. The installation from this point on is very easy. For the details, you can also watch one of my Raspberry Pi 5 videos on how to install Windows 11. The only thing to note is that initially you would not be able to use Ethernet adapters because there are no device drivers available at an installation time. Luckily, you can install them later through the command window by running the driver's installation script, which automatically installs all of them. A zip file with Windows 11 device drivers is available from OrangePi's website. However, the drivers are not digitally signed and therefore you have to run Windows in test mode, which you can do by setting test signing flag with bcdedit command from a command window with administrative privileges. To be able to install Windows without an active internet connection, you have to select the option I have no internet connection, which is not available with newer versions of Windows, but they currently don't work anyway. I suspect that the main culprit for this is BIOS. I have the latest version, which is 1.3. I hope that there's going to be a newer version in the future that would support versions of Windows 11, like 26H1 and forthcoming 26H2 and maybe even Windows 12. But it has to be noted that OrangePi 6 Plus doesn't have a trusted platform module 2.0, and this would probably be the limiting factor for the future versions of Windows, which may also not work on Raspberry Pi 5 for the same reason. However, it is possible to add such a module through the expansion port, which is also mentioned in the user's manual. Let's now talk about OrangePi 6 Plus's performance. I've tested it on OpenShot editor, which I use to edit my videos. Though it's not using the inbuilt graphics processing unit acceleration options, it is still about 3 times faster than my old PC, which is also only using CPU power. Running large language models with a neural processing unit is also incomparably faster than on the old PC because it's got no AI capabilities. Amongst very important speedup factors is also the SSD drive, which is attached through 4-lane Gen 4 PCIe bus like on any newer classics PC, which enables burst rates up to 8 GB per second, but I only have an SSD drive that supports Gen 3 standard, so it's half the speed. I've used Crystal Disk Mark to measure the SSD performance, which is about 4 times faster than an SSD drive attached through 1-lane PCIe bus Gen 3 on Raspberry Pi 5. I've also installed some very old applications, like CoolEdit, and they work flawlessly, though they are written for Intel and AMD architecture. Newer applications that are specifically built for ARM64 architecture work far more efficiently. As I've been using OrangePi 6 Plus, I've also learned certain tricks. There were many questions in the past, for example, what to do if the only HDMI port stops functioning permanently. Of course, in this case, you could use an Ethernet connection and remote access. However, not all operating systems allow you to change BIOS settings remotely, and even if they do, you would need a special application. There are also 2 other options: connecting your monitor through a USB-C port or through the DisplayPort. If your monitor has a DisplayPort, you only need a DisplayPort cable. Otherwise, you'll need a DisplayPort to HDMI adapter. Another option is USB-C port to HDMI adapter. I've bought both adapters for around 14 euros each. I've tested both of them separately and together. What is intriguing is that BIOS setup screen is only available on the preferred adapter. USB-C to HDMI adapter is connected, it is preferred, but if it's not, then DisplayPort adapter is preferred over HDMI cable. However, it has to be noted that Windows 11 only supports the preferred adapter. If you want to select another adapter, the easiest way is just to disconnect HDMI part of the cable, and the second preferred adapter would be used instead. Let's now talk a little bit about Wi-Fi and Bluetooth communications. Installation of the original OrangePi Wi-Fi and Bluetooth adapter to 1-lane PCIe 4.0 E-type port is optional. The 2 antennas are pre-installed, so the only thing that you've got to do is to insert it into M.2 E-type port and fix it with an enclosed bolt. Wi-Fi and Bluetooth adapter not only works on different kind of Linuxes, but it also has no problems with Windows 11. Everything works out of the box and no additional device drivers are required. RPi5 Plus is an excellent computer which can be used in many products where small form factor and a high processing power are required. If you've liked this video, please press like and subscribe buttons and don't forget about the notification bell. If you'd like to help this channel growth, hype this video as well. See you in the next video. Bye.